All right, so Riley and I are here to talk a little bit about special products. This is my dog Riley, so now she's been in a video. Officially she's famous and she's been on YouTube. All right, see you later. Anyway, we're here to talk about special products, just an extension of what we've been talking about with FOIL. So when we talk about special products, what we really mean is patterns that result from these special cases of multiplying polynomials. So it's not that these are problems that you couldn't have done previously. It's just the idea that you're looking for patterns instead of going through the whole foiling process. So the two different cases you have is when you have these ideas of squared, a plus b squared, meaning the parentheses are repeated. So it's either a plus b, a minus b, a minus b, a and b just standing in for whatever components you have of your binomial. And the second case would be a plus b, a minus b, meaning you have the exact same components in your parentheses, so maybe x and 2, x and 2. It's just one of the parentheses is an addition and one of the parentheses is a subtraction. So those are the two cases, two general cases you should look at when you talk about special cases. So the shortcut, kind of looking at patterns, and this is what that half sheet, hopefully you kind of got the idea behind it, but the pattern would be when you have this parentheses repeated, so again this is a plus b times a plus b, is that the result is the first term squared plus 2 times the two terms multiplied plus the last term squared. So you can use this pattern, and I'm going to do a problem here. You can use this pattern to help you just kind of shortcut around the FOIL process. So if I look at this, kind of look at what I've written above, almost like it's a formula. A is whatever the first term is, B is whatever the second term is, and I basically fill in my formula from there. So my formula says it's the first term squared, so it's 2x being squared. It's 2 times the two terms multiplied together, and it's the second term squared. So if I simplify this, 2x squared is 2x times 2x, which is 4x squared. 2 times 2x is 4x, times 3 is 12x, and then 3 squared is 9. Just kind of a shorter way, once you get the hang of it, to go through your FOIL type situation. So if you want to pause and try these two using the method we just went through. So again, this is A, this is B. So it's a squared, which is 3x squared. And then it's plus 2 times a times b. So a times b is 21x. 2 times that would be 42x. And plus b squared. So b squared, 7 squared, 49. It can be applied to, so this formulas can be applied to more complicated situations as well. Throwing in some multiple variables is just follow the exact same pattern. It's a squared, so 2x squared, plus 2 times 2x times 3y. So these two multiplied would give you 6xy. 2 times that would be 12xy. And then b squared would be 3y squared, so that would be 9y squared. So again, 2x squared, 2 times 2x times 3y, and 3y squared. So when you have the same parentheses repeated times themselves, it's just, again, noticing the patterns can help you move through things a little more quickly, and noticing the patterns can also help you eventually. So we're going in this direction right now. Next, we're going to be working on going in the opposite direction. So noticing those patterns can be helpful. So what's the difference now when we have subtraction? So again, it's still repeating. It's a minus b the parentheses are repeated, but there's a subtraction instead. The shortcut, the formula, looks very similar. And if you need help working through this formula, you could, or where does this formula actually come from, you could actually FOIL out a minus b times a minus b. And what you'll find is this general format, you take, and in the I do, the only difference between the first setup we had, the first special product, is that middle term becomes subtraction. So it's still a squared, so 3x squared, minus 2 times 3x times 2. Notice the b term here. I'm not taking the minus sign into account. The minus sign is taken into account because I used this particular setup. Notice this is the a term, this is the b term. It doesn't say anything about, you don't have to take that negative sign into account. So this is just, the b term here is 2. And then it's always plus the b term squared. So this is 9x squared minus 12x plus 4. So again, another one for you to try. Maybe a little bit more of a challenge, but go ahead and pause and try it. So again, a is 7x here, and b is 2y, not negative 2y. It's kind of against what we've done in the past, but you're kind of plugging this into a formula. So it's the first term squared minus 2 times the first term times the second term plus the second term squared. So that'd be 49x squared minus 14 times 2 is 28xy plus 4y squared. So again, a squared minus 2ab plus b squared. So the same thing, same sorts of patterns can help you when we're talking about this pattern. So same components in the parentheses again, a and b, but one is plus and one is minus. When you FOIL this all out, when you multiply it all out, what ends up happening is you end up with this pattern because of the FOILing. A times a is a squared, a times b, or sorry, a times negative b is negative ab, b times a is plus ab, and b times negative b is negative b squared. Notice those two middle terms cancel each other out. So this is what we refer to, and we'll talk more about this in the next chapter, but this is what we refer to as a difference of squares. The result here is called a difference of squares because there's your square terms, and difference means subtraction. So we use this special name to talk about this particular relationship. So where this relationship really saves you the time is if this is A and this is B, all you have to do, if you notice that one's plus and one's minus, your parentheses, it's A squared minus B squared. So 9x squared minus 4. Saves a little bit of the hassle in FOILing. More so because really looking for patterns is where we're headed to next. So if you guys try this one, this is the last one. Pause, try from here, but to finish this off, there's your A term, there's your B term. One's minus, one's plus, so the pattern is the difference of squares. So the first term squared minus the second term squared is 81x squared minus 16. So patterns are what we're looking for. Patterns exist in all of the multiplying we've done, but these are some specific ones that we'll see come back again.